Hello guys, welcome to the second half of the class. In this session, I'm gonna basically move on with the lecture and talk about user-defined functions. Now, user-defined functions are very different from the predefined functions because in the predefined functions, what you were doing essentially was learning the structure of a specific function and using it. So as long as you know the how many variables and what type of variables the function accepts, you can use any predefined functions. However, this is not the case with user-defined functions because you create the user-defined functions yourself. These functions do not exist in C++ library, but rather you create them so that you can shape what you want to do with them. They are extremely useful, and in the upper classes, if you're going to take a visual programming class or computers and algorithm, you will see that these are most frequently used with scenarios where you're going to structure the program itself. In other words, they are more oftenly used than predefined functions, and you need to learn. Probably one of the most important topics of this course is this one. You need to learn how to write user-defined functions. There is no other way if you want to learn structured programming. What happens in here is that you define the function yourself, just like you define a variable. You define how many parameters, in other words, variables, it's going to accept. And based upon this, you define the features of the function. There are some specific things you need to be aware of, such as function name. Any valid identifier can be the function name. This includes all the rules we have been following for naming our variables. The return value type is the type of the function, such as integer, float, double, and at the end, it must return to that specific type. Not the value might change, but the type must be the same. Finally, it is possible that you can write parameters into the user-defined function and allow the function to basically operate on these parameters. They can be separated with commas, and their data type must also be included. As a matter of fact, you know functions a little bit because you have been writing the main. The main is a function, and its return type is integer. And as you can see at the end, it always returns to 0, meaning that the program was completed successfully. The main function does not accept any arguments, but it is possible that you can type void inside. When you do so, it means that this function does not accept any arguments, and it doesn't make any difference in the program, as you can see, because it runs and there is no error. So in this case, the void is a placeholder for scenarios where you are going to you are not going to pass any parameters, but rather indicate that the function itself does not have a return type or does not accept any number of parameters. So going back into the subject, we have a couple of things we need to be aware of. First, the function name. This has to be named by you. Okay, you give it a name, just like you give a variable a name. You give it a type, just like you give a variable type, and it always returns to that type. If the function does not have a type, then you say void, as I told you, and you do not return to any value. And finally, you can accept any number of parameters into the function, 2, 3, 4, 1,000, only one, or none. And if you're going to use these parameters in the function, their values are only affected inside the function itself. It's not going to be affected in anywhere else. As I told you before, main is a function, and you can use this. So main, when you write this, you can put void inside if you want to. This is optional. And when you do so, at the end, you always return a statement. You can do so using the functions in the same way. So when you write a function, unless you call the function, also called invoking the function itself will never be activated. The functions are only activated when you actually call them inside the main method. This is the part that confuses students. Students usually assume that as they wrote the functions, it will be triggered automatically, but this is not the case. The function itself is only invoked, only activated, when you deliberately call it inside the main function. Unless you do this, the function is not going to be active. The only function that works by default is the main function. So just to show you an example, if you write a function named display just to say hello world or my first function in a program, you can write it at the beginning, just before the main. There is an alternative way to do this. You can also write it at the end, but it's very C style rather than C++. In C++, you are supposed to write it at the top rather than the bottom. In many languages nowadays, it doesn't even matter if you write it before or after, but because C++ is an improved version of C, it supports one style over the other. Finally, when you write the main function, unless you call the function itself, it will never be activated. So you can write this function here saying that void display means void, it doesn't return to any value. This void can become integer, can become float, can become something else. But when you do that, you also have to return to a specific value. If you do not do that, if you don't want to type return, then you just type void. Then you give it a name. I gave the name display. You could put your name in here if you want to, doesn't matter. Once you have done that, you write a statement here that will be executed inside the function. However, this statement is not going to be displayed unless you deliberately call it inside the main function. Only when you call the statement inside the main method, then the display function will be activated. This stage is called invoking the function or calling the function. This one is called the body of function, which means what the function does. And finally, the definition of the function is called its declaration. So sometimes this is also called the prototype of the function, which means that its definition is defined. Okay, so when you run the function, the display part will jump in here during the runtime. The computer will start running the function from main. It will never actually run the display. It will start running the program from main. As soon as it sees display, it will jump here, execute the statement, whatever you wrote there, and then once it is finished, it might return to a value or not. And finally, it will return 0, which will display you my first function. Now, this is the theory of it. We're going to write a program and we'll understand it better when we do so. Another way of writing the functions is also defining the function first, then calling the function and typing the body separately. I prefer the first way, where you define the function and type the body together at the beginning. But the old C style also allows you to write them separately if you want to. You can write the function prototype declaration at the top, then call the function, and when you call the function itself, it executes the body. So this basically is defining the function, just like how you define variables. When you write integer main, integer x, integer number 1, integer h, you basically define the variable before you use it. So the function declaration is more or less the same thing. you declare the function before you use it. Then you call the function, and when you call the function, it jumps to the point where it executes. So you can use the first way and put the declaration and body together, just as we did in here. Put the declaration and body together in the first part and just call the function. Or you can do them separately. It is up to you how you want to do it. Here's an example that we're going to solve now. Write a program which will get two integer numbers from the user and display their summation. Let's make this a little bit more difficult and find their average rather than their summation. So we're going to get not two, but three numbers, first, second, and third. And then instead of sum, let's find their average. We have so many different average questions in this course, and this is going to be just another one, but with functions. So before I solve this question, do you have any questions about functions? Any part that you did not understand so far? Yes, that's a no. So let's define function question. So because I use the standard statements, I'm going to put them in here and put the question as well at the beginning, just as we did with the other one. Enter three numbers and calculate their average in a user-defined function called find ave, which accepts three integer values and returns a float value. So from this question, you can understand the prototype of the function. The function name is findAve, which means find average. It accepts three integer values and returns a float value. And its job is to find the average of the entered numbers. So once you have defined this, we're going to type using namespace std and return 0. You can see in here that the style is going to change now with the program, because the function declaration or the body should go somewhere in between integer main and namespace std. Every single function should be defined outside of the main function, because they are not local, they are generic to the program itself. So you can define the integer values in here, but the function itself should be defined outside of the main. If you look at the function prototype, the function name is findAve. It returns a float value, which means its type is float. You can say find average, and you can also define three integer values. These integer values are the values you are supposed to accept inside the function. Once you have defined this, you can use the first way or the second way. I like the first way more, but this doesn't mean that my way is the correct one. Remember, in programming, I told you a million times that there is no one absolute way of solving questions. There are multiple approaches, okay? And just because this is the way that I solve the question, it doesn't mean that it's the only way. What I'm going to do in here is that I'm going to use the first way, but you can also use the second way if you want to. In the first way, we were basically keeping the body and the function definition together. So that is what I'm going to do in here. So I'm going to put integer numbers in here, A, B, and C. You can keep these numbers exactly as they defined in the main, such as n1, n2, and n3, but they're not going to be n1, n2, and n3. They're going to be something different in the RAM block. So even if you give them the same name, they do not actually occupy the same space in your computer memory, hence why their values can change. So you can name them as n1, n2, and n3, but they're not going to be exactly the same variables, even though their names are the same, because these ones are defined inside main, and as soon as these ones come in here, they are now inside find average. You can think them as sets, basically. That is probably the easiest description that I can give you to explain how this works. So you all know sets in programming, in math. So whenever you basically do operations in sets, there is a set in here. Let's make this no fill. And there is a set in there as well. These sets can have intersections, but they can also have different values. It is possible that this set name is, let's say, A, the first one, and the second one is B. So you can think that each of these functions themselves are actually like sets in math. Whenever you define set A and set B, they can include similar components. This doesn't mean that the components are the same. So this set can have an X value. Let me just make this a little bit bigger so that you can see it. Yes. And I'm going to put no line here so that you can see it. Yes. So this specific A set can have an X value, can have a Y value, can have, let's say, a Z one. Assuming that you can have also same values for the B. It is possible that the B values can be the same or different as well. So we have an A set, we have a B set. In the A set, we have X, Y, and Z. In the B set, we have B, A, and X. You see two of these values are the same. So this creates some sort of confusion. How do we reach to the value of X in A and the value of X in B? In programming, what you do is that you say something like this: A dot X plus B dot X, referring to the AX or BX. If you get confused of which one has which one, you can also name their different. So you don't have to name them X, you can name one of them as X1, one of them as X2. But know that their values will be different or not related. The same thing happens in here. Whenever you want to find an average of a number, n1, n2, and n3, you can pass exactly the same values here, but you can also keep them different because they do not have any more connection. Now, once they pass to the threshold to the user-defined function. Now that we found this, we have the values. We're going to define an average here. And we're going to say average is equals to A plus B plus C divided by 3.0. Now we found the average, but this function will never run unless we call it deliberately inside the main method. What we want to do in here is that we need to make sure that we call this function. Before that, I'm going to ask the user to enter the numbers. Enter number 1, get the number, and 1, 2, and 3. Once we got these numbers, we need to calculate the average. Again, you can use many different ways to do this. You can directly call the function itself. Remember that once you calculated this, you need to return. By returning, I mean that you return a specific value. Only one value can be returned. You return that specific value, and when you call the function, now that value is returned to the place that it was invoked. So you can say something like this: find average, which is the function, find A, and pass these values inside, which is n1, n2, and n3. When you pass n1, n2, and n3 now inside the function, it will jump automatically to here, initialize A to n1, B to n2, C to n3, do the calculation, and return whatever result that it obtains here so that this can be displayed. So we can say something like this: average of numbers to whatever function that you have. As an alternative approach, you can also initialize the function call to a variable, and that's okay too. Let's try to run this. I'm just going to put C in ignore and C in get and run this application. As I run it, it asks me to enter a number. I'm going to enter 20, 10, and 5. And the average of numbers is 11 point, repeating 6. And as you can see, it shows exactly like that and finds the average. You can see in here that the main function does not do any calculation. It only gets the input and shows the output. The functions are a perfect way to differentiate the process from input and output. This is particularly useful when you want to build a program with others. Because, as you know, programming is not a lonely job. Most of the programs that you use today are generated as part of the result of teamwork. So when teams come together, they can actually divide the job now. One of them can focus on getting the inputs and outputs. The other person can completely ignore that part and focus only on delivering the results, the calculation. Okay? That is why user-defined functions are important. And another important feature is that every time that you want to calculate the average of a number now, because you wrote this thing, you can basically calculate the average for many different numbers. You don't have to basically just write one in here. You can call as many as you like, such as if you want to put numbers in here for static values, average of 1, 5, and 7, you can basically put directly these values 1, 5, 7. Okay, they will be initialized to some kind of variable. In order to do that, it's better if you initialize them. So we can say something like a is equals to 1, b is equals to 5, c is equals to 7. So all you have to do is to change this now to a, b, and c, which will allow you to run the program direct. 1, 5, 7, 1, 5, 7. So we can run the program. Oops, we have a problem. I think the program is already running, so that's why you get the error. I close the program. And now the program asks me to enter a number. I'm going to enter random values 5, 8, and 11. The range for the average 5, 8, and 11 is 8. And you can see the average of 1, 5, 7, 4.3 repeating. This means that once you have written the function itself, you can use it as many times as you like. That is why functions are very useful to provide reusability. Okay, there are many different ways that you can write these functions, such as if you want to calculate the average of a specific number, you can simply type float average of ABC, for example, and you can come in here before you initialize it to the value itself. Average of ABC equals to find average ABC, and instead of directly showing that the function, you can actually show the variable. It is possible to write this in many different ways. Okay, this is just my style, as I told you, and in order to develop your style, you must try it yourself. Just by watching these videos, you will never get an expert in programming, or you will never actually be a good programmer. What you need to do is to practice these yourself so you can develop your own style. Much like driving. You can understand how to drive a car, but unless you try it yourself, you will never be good at it. And the same goes for programming itself. Now, any questions about user-defined functions? Anything you did not understand in this exercise? Is everything clear? Good. So you understand this part. There are many different exercises in here in the user-defined functions. You can also find them in your lab sheet that I unlock every week. And they are explaining quite detail here. As you go through the slides, you will see that both ways are actually explained in quite a bit of detail. First way, which is the one that I like, is to write the body and the basically the body and the declaration together, which is displayed on the examples. And you can also write them separately, just as you can see in here. You can type void at void, which means there is no return value and no value to accept. In this case, this creates something called a global variable. A global variable is something that you can assume in the set example that we gave, something that exists within the intersection. So basically, when you write the values themselves, if you discover that you're going to use a value too often, you can basically define it in the middle rather than putting them separately. You can define a value in the intersection, like in here. This will allow you some advantages, but also some disadvantages. The advantage is that both functions can access to the state of the x value. Now that you kept them separately, you can basically allow the user to access to the state of x. But once this value is changed now, it will be changed permanently. So whenever you change the value of x from a, that change will automatically be reflected to b. And this is called global variable. The local variables are variables defined in a function that no one else can directly access. Okay, such as in this case, a, y, and z are local variables of function a, and c, a, and b are local variables of function b. So the value in a in the b and the value in a can be completely different, even though they have the same name. However, the value of x being seen by a and the value of x being seen by b is basically once the state changes, it is reflected everywhere in the program. Global variables are not something that we encourage, to be honest, unless you are dealing with a situation that you don't want to pass the values to the function. You should always pass the functions before you do them. Okay. But there are circumstances that they can be useful. To define a global variable, you basically define a value outside of functions. So as you can see now in your program, you have two different functions. One of them is called findAv, which I minimized it. The other one called integer main. If I come here at the top before the functions and type something called integer k, this value is global. So whenever I give a value and change its state, let's say k value is 2, and I want to access to the k value, you can access the k value in here, k value in find a function. It is possible to access its state, and you can also do that in the main. However, this is not something we encourage because it is very difficult to follow up what was the final value of k in case that you lose the track and it is accessed by many different functions. So it is not something that we encourage that much. So whenever you write the program now and you enter some random numbers, you will see that the k value in findA function is 2, and the k value also is being displayed in the average twice. Each time you run the function, you see that the average is being run twice. So I'm just going to minimize this to see the k value only twice. So k value find average 2, average of numbers, and k value also again in the main function. So if you actually start the value of k as 2, but in somehow change its state in one of the functions, such as let's say k++, this change will also be reflected to the main function. So once you have basically showed the value of 2 in here and then increase it, it will actually reflect that in the main function. Because once you have changed something, it will be automatically reflected to the next function. So you see it started as 2, but because I put plus plus in here inside to find average, now in the main function, it's going to be 3. Okay, this is why it might be difficult for you to follow up the very last value when you define a value global. Hence why it is not something we encourage in programming. Okay, there are very strict, very specific circumstances that this can be useful, and it will be useful in the future. But it's not something we're gonna use in this course. If you're gonna take more programming classes in your degree, such as become a computer engineer or IT or very programming specific uh, measure, then you will learn much more about the definition of global variables. So that's all. That's all I wanted to talk today about functions. So you see there are more examples in here. I think I'm going to solve one more example and move on with the subject. And I'm already finished it. Before I move to the example, another example, and solve it, do you have any questions to me? Seems like your awkward silence means no. I'm going to move and solve another question and be done for today. So we have one more chapter left called arrays, and I'm going to complete that one next week, hopefully. So we are reaching now to the end of the semester very soon and almost finish all the subjects except the very last one. So I'm going to come in here, include IOStream using namespace, all this stuff that I want to copy, main function, 0, and define as I'm gonna write a question here. Question. Ask the user to enter two integer numbers and offer them a menu to execute either a summation or subtraction in between these numbers. Let's say with these numbers. Ask the user to enter two integer numbers and offer them a menu of choice which they can select to execute either a summation or a subtraction with the entered numbers. Both summation and subtraction be executed with the following user-defined functions. So we're going to give you the prototype. I'm going to say something like integer add. Just make this float actually, because in the future you might want to add a division. Integer a, integer b, and float subtract integer a, integer b. So you can see from this question that you need to offer a choice menu to the user, which then they can select to perform a summation or subtraction operation after they enter two integer numbers. Okay? After they enter two integer numbers, you can offer them a menu to perform a summation or a subtraction operation. And both of these should be executed with user-defined functions. And their prototype is also given in here, float at and float sub. So to start this program, first of all, define the numbers, integer and 1, integer and 2. You are going to basically ask the user to enter. Cout, enter first number, cin, and 1. And the same thing goes for second number. Once this is done, offer them a choice menu. Operations to perform. I'm going to put some lines in here. Add numbers. First choice. And the second choice is subtract. You can basically ask the user to do whatever they want. Enter 1 or 2, please. And we're going to get that as the choice. So I'm going to put integer choice. You can use a switch or an if. I'm going to use a switch. Sometime I haven't used it. Case 1 will refer to the first case, which is entering 1. And case 2 refers to the second case, entering 2. You can also leave a default and tell the user that you are expected to enter 1 or 2. Please enter 1 or 2. Other number, accept. And we can basically break the program. So let's try to run this thing, even though we haven't typed any functions or anything, just to see how it's going to flow. I'm going to run this application. I'm expected to enter a number. Let's enter 2 and 3. Then it pops up a menu, add numbers, subtract numbers. You can see the menu here. I enter 3 and it says, please enter 1 or 2. No other number is accepted. So basically, if you try to pull the program, it will basically pop up an error message and tell you that you must enter 1 or 2. No other option is available. Once we have done this, we can now focus on performing the operations of add and subtract. Remember that you can type them at the top or you can type them at the bottom. Doesn't really matter. But if you're going to type them at the bottom, make sure that you pass the prototype. I'm going to show you with both ways. All you have to do is, if you want to define them at the bottom, define the prototype here, which is without the values, just the name of the function. So you just tell what type of data it will accept. And when you come down here, after the main function, you can minimize the main. You do the operation. You don't even need to know what the content of main is in order to write it. And that is the beauty of user-defined functions. It's completely independent from main. So you can type whatever you like here. I'm going to type integer a and b and say something like, you can directly return them a plus b if you want. That is one way. You can also initialize a value of the same type. Let's call the sub in here as an alternative approach. You can define a value. Total is a minus b. Again, you have multiple ways to type it. You can type it and return it instantly, or you can initialize it to a value first, subtract it, and return the total. And I don't even have to know what's inside the main. I don't care about it, because when those numbers come inside the function, it becomes a and b now, completely different values. So it is a big advantage in here how to deal with them, because then you can minimize those functions and focus on what you have in your hand to do the operation. So if the person basically selected one, the function that you're going to type is add function, because one refers to add. You can define a float number in here as a result, and result can be add whatever numbers are being entered, n1 and n2. Remember, inside the main, the numbers are n1 and n2. Inside the add, the numbers are a and b. Do not confuse them, okay? You can give the same name to them, by the way. You don't have to use different names, but if it happens that they are different, make sure that you do not confuse them. The same thing is going to happen for case 2 as well. But this time, we're going to say sum. If you want to show the result, you can simply say result is equals to result. And you can basically do this at the end, should you want to, just one, so that we don't repeat the code over and over again. And we can put 0 here. So if the case is run, it will calculate the function. If it doesn't run, well, it won't calculate anything and become 0 automatically. Result is automatically 0. Just to mention to the user that we display 0. If anything goes wrong, we will just keep displaying 0. So that's it. As you can see, one way of doing this is putting it at the end and definition at the beginning. Let's see if this is going to work. So we are expected to enter two numbers. I'm going to enter 5 and 9, and I'm going to select 3 and say that please enter 1 or 2. No other number is accepted. The result is 0. Let's try it again. 5, 6, subtract. No, I'm just going to enter some gibberish data. And please enter 1 or 2. No other number is accepted. Now I'm going to enter proper data this time. Let's say 8 minus 1 and add the numbers. Even though I add them, because one of them is minus, the result will be 7. If I try to run this again, let's try to run it. This time I'm going to basically subtract them. 9 and 6. Subtraction will be 3. So 9, 6, I selected 2. Please enter 1 or 2. I selected 2, which is subtraction. And the result is 3. So basically, when you put 1, the first function runs. And when you put 2, the second function runs. Just to show everything in a very detailed way, you can say that whenever you run select the first choice, it goes to the add function and executes it. Whenever you select the second one, it goes to this part. It also refers to the functions in there as well, where their bodies are. So first one is the add. So we know that the first one will jump into and execute the add function. And the second one will jump into execute the second function. You can also write this in a different way. Instead of putting the definitions, you can basically copy this and ignore the definition here. Just copy paste the functions at the beginning, which is the way that I used in the previous question, and immediately run it. The program is already running. I need to close it. Yes, now it works, as you can see. So whenever I make a selection this time, let's say 5 and 3, and if I select 1, the result is 8. So first value goes into A, which is 5. Second value goes into B, which is 3. A plus B, 8, is calculated inside the add, and it returns in here. How does it return? It returns because the main function basically initialize add to the result, and the result is displayed. So that's it. That's all I want to say about user-defined functions. Do you have any questions to me? It's been almost 2 hours that we are doing the course. Any questions? Is it clear? I recorded these sessions, guys. It's been being recorded now, and I will upload them to Moodle into the class archive section. Okay, I stopped doing the YouTube tutorials because it was taking too much time from me in the future, and I also don't have a good microphone, so my voice wasn't very good in the recording. And I will upload them to the online class archive section. So if you go there into the online class, you will be able to find the date of the course, which is today, and you will be able to watch it. Okay. From this panel, I am creating you a playlist, and I will upload this video with today's date, and you will be able to watch it on YouTube. One last thing before you ask me questions, either on Moodle Messenger or other places, please watch these class videos, because you are not the only person having these troubles or problems. There are other peoples as well. And when we share them all together in the class, it's a much better approach than asking questions one by one. While only around 30 to 40 people come to each section, this course is actually being taken by or more than 300 students. So and most of them do not come to the class, and they keep asking questions all the time, like what is the content of midterm exam, what is this, what is that. And this is not a good idea, because if I answer to your emails and messages all day, then I should do nothing but just answer questions. And I am not only teaching this course. I have other courses, other projects, other duties to perform, other stuff that I need to do. I wish this was the only course that I was teaching, so I could pay attention to you more, but that's not the case. So please try to understand that we need to discuss them in the class so others can watch them. I'm gonna end up today's section now and upload the videos. Before I do that, do you have any questions to me? Okay, no one has any questions. I don't see any hands being raised, so thank you for coming to this session. I appreciate that, even though more people should come. Only 30 of you show. And I really appreciate you guys coming and providing feedback. You are actually, in a way, defending of people who do not come to the class at all. You are being a voice for them. So thank you very much. I'll see you guys next week. Don't forget that you have an exam this Sunday. Make sure to attend it. Have a lovely day. And as I told you, I will upload this video on YouTube so you'll be able to watch it. Take care.